So if you have any questions from those problems or from previous things is okay too. Anybody? Victoria. 35 or 34? Sure. Do you have a preference there? No? Okay. Does anyone else have a preference on 35 or 34? Nah, man? All right, we'll do 34 then. So it says use synthetic to determine if all of the real zeros of the polynomial lie within the interval -5 to +5. So basically all we need to do here, come back please. Not that that helps. Come on. Come on. Don't mind me while my computer's just like having a stroke here. Did it? Okay. All right. So 34, what this basically breaks down to is I just need to do 2 synthetic divisions and look at the results. So the synthetic divisions I'm going to use are going to be with the endpoints for the interval that I'm concerned about. And I'm going to be doing that synthetic division on the polynomial in question. Why am I putting this extra 0 in here? Great, because I'm skipping the x squared term, so I have to put a 0 in there as a placeholder. Bless you. All right, so this is my setup. So grind through this. Oh my goodness, 140 or something. Do the same thing down here. Okay, so far, Victoria? Okay. So what I need to do now on the -1 to check to see if that's a lower bound, which it should be since it's the beginning of our interval, the numbers here at the bottom have to alternate between non-negative and non-positive, which is what I'm seeing, right? I see positive, negative, positive, negative. So that's what I'm looking for there. To check to see if I'm an upper bound, where it's the end of the interval, the other end, the upper end. All I need to do is these numbers underneath all have to be non-negative, which they are. So yes, negative, all the zeros are between -5 and +5. Good morning. Good morning. Does that feel okay, Victoria? So the thing to remember is just the lower bound, they have to alternate, and the upper bound, they have to be all positive. Let me double check that there's not one extra constraint in there. Let's go back and look. We did this, I guess, on the 15th. Okay. So this theorem only works if you're bounding it between a negative and a positive number. So the positives, to be an upper bound, they all have to be positive. And the negative can only be a lower bound, and they have to alternate. I thought there was one extra criteria in there. Who's next? Jane. Oh, sure. I forgot to mention we had the worksheet too. But we can do that. All right, you say 3. All right, so we're asked to find the, to solve the equations here. So in 3, the equation there in question is a quadratic. To solve a quadratic, I have to first have it equal to 0. So I'm just going to subtract 20 from both sides. And now I'm going to look to see if there's a greatest common factor. So obviously there's no variables that are a common factor since I have a constant term there. But let's check the coefficients. Is there anything in common between 7, 31, and 20? No way, homie, right? The only factors for 7 are 1 and 7, and those definitely don't divide. Well, 1 does, but like, who cares? But 7 surely doesn't divide 31 or 20, so okay. So what this tells me is that I can do this 2 different ways. Since we're solving, we could try to factor this. Maybe it'll factor, maybe it won't. I'm not sure by looking at it. Or I could do the quadratic formula, which I know will always work. That would be the choice that I would make here. So if you remember, the quadratic formula says x equals negative b plus or minus b squared minus 4ac all over 2 times a. So I'll just go ahead and type that in. Notice that on my calculator, I can't do a plus or minus. So I'm just going to do once with the positive and once with the negative. I use this fraction command here. You have to be a little bit careful about doing that because if you're getting an imaginary result, I don't think the calculator is going to handle the imaginary results with the fraction command. I don't think it's programmed to be able to accept that. But here I can tell, since I'm minusing a negative, that I'm just going to be adding these 2 things, so I'm not going to get a negative there. So I get 5 for one of them. And then if I change that to subtraction, I get negative 4/7 for the other one. Does that feel okay, Jane? And again, this turned out it was factorable. If you wanted to factor it, we could factor it, but I would just do the quadratic formula if I'm solving for something and the leading coefficient isn't 1, because quite frankly, the quadratic formula to me is probably less hassle than trying to factor it, because if the leading coefficient isn't 1, the factoring's not trivial. It's kind of a pain in the tuchus. And I'd rather just do this because I'm guaranteed to get an answer. You know what I mean? Worth pointing out, too, a common mistake I see students make, particularly at this level, is when you type that negative 31 squared in your calculator, you need to make sure you put a parenthesis around the negative 31 with a squared on the outside. Your calculator is going to make, there's a big difference between this and this. Those are not the same value. This is the one that you want. So make sure when you're typing it in your calculator, you're using that set of parentheses. As an aside, you know, like, I know you guys know this, but it's review, man. We're just talking, right? Anybody else? All right, cool beans, dudes. Let's finish this chapter up then. So today, 13.4, the finish. So remember, what we've been working on here, this chapter has been finding the zeros for polynomials. And at this point, we are ready to do the most complicated versions of these problems. Okay, so here the directions say find all of the zeros for f of x equals 8x to the fourth minus 26x cubed plus 27x squared plus 62x minus 35. When we say all of the zeros, that means that we could have imaginary things. We could have duplicate solutions, those are the multiplicities, and we could have irrational zeros, things like square root of 5 or something that you can't synthetically divide to find. Okay? So just looking at the graph is not going to be enough for us, right? Just looking at the graph and reading the x-intercepts will not be enough because you could have multiplicities. Can't really tell that from the graph. You could have imaginary things. Can't find them on the graph. You could have irrational things. You can't find the exact value of that irrational zero just from looking at the graph. So we really are stuck using this method if we're looking for all of these things, because there's possibilities that could pop up that just you can't find any other way. Okay. So using the fundamental theorem of algebra, I can determine right away how many zeros I should be looking for. How many are there in this case? 4. The degree of the polynomial tells you I have exactly 4 zeros. That means when I say exactly 4 zeros, that means we're counting imaginary things, we're counting multiplicities, we're counting it all. But if you count it all, you get exactly 4. Everybody's cool? The next thing we're going to do is we're going to find those possible rational zeros. Remember, those are of the form P over Q, where P is the factors of the constant term. So the factors of 35 are 1, 5, 7, and 35. And Q is going to be the leading coefficient. So the factors of 8 are 1, 2, 4, and 8. So my possible rational zeros are 1 over 1, 5 over 1, 7 over 1, and 35 over 1. And then I have 1 over 2, 5 over 2, 7 over 2, 35 over 2. And then I have 1 over 4, 5 over 4, 7 over 4, 35 over 4. And then 1 over 8, 5 over 8, 7 over 8, and 35 over 8. Is everybody okay with how I came up with that list? It's all the factors of P divided by all the factors of Q, right? With plus or minuses in front of everything. All right, so that's, what do we have? We have 32 possibilities there. Woof. I'm not doing that blind, right? That's a lot of things to check. Back in my day, that's how we had to do it. We have access to graphing calculator. Let's use that. Oops, got to change my mode from the other class I was working with. So we'll start by typing in my function here. Okay. I've been doing all kinds of graphing for other classes, so to graph this, I'm going to do the zoom standard here because I don't know what my window is set as. Oh, and my axes were turned off. 1 second. Oops. For a different class, I had turned off the axes so we could see something a little bit easier. You turn that back on. All right. Just double check I typed that all in correctly because that picture is not quite what I thought I was going to. Oh, yeah. -8. Try again, Mr. Kulik. That was -35 at the end. There we go. I was like, that didn't look right. There we go. All right. So I see 2 x-intercepts on the graph. You guys agree? This one appears to be a little less than -1. I can see it's not exactly -1 because if you look really closely, you can see the tick mark for -1, and the line's definitely passing left of that tick mark. So I'm going to go through my list of values here and see if there's anything that looks like less than -1. Well, -5/4 looks pretty good. Everybody okay with that? And then this one over here is just to the right of 0. So maybe that's +1/2, or maybe it's +1/4, or maybe even it's +1/8. It's hard to tell. You know, the calculator resolution is not such that it's usually really easy to tell that. Landon?
The last one, when you're looking for like the one past -1 over, like -5/4 because it's closest, like it's the closest to -1 without going a lot over it.
Yeah. So if I look at the rest of these, like -1, -5, -7, -35, -1/2, -2.5, 3.5, 8. What is that? Like 14.5 or something? No, better than that, but whatever. -0.25, -2.25, -1.75, -10-ish. None of these look close, right? I keep going, and there's nothing. This is the only thing that's even close to -1, other than -1, but I can tell it's not because it's not going through the tick mark. Here it's a little bit harder to tell. It's probably 1/4, but I'm not totally sure. but it'll be like one of those, right? Or a half, I'm not sure. Okay. So which one of these would we choose to start our synthetic division with? Come on, man. I would do the negative 1.25 because there's really only one thing that could be, right? I'm pretty sure that's what that has to be. So I would start with the thing that I know rather than guessing there. And we'll start our synthetic division. That's going to be negative 10. And it's too early. Mr. Kulik's getting the calculator before he goobers it up or something. There we go. 45. We got, oops, that was 72, negative 90. It's positive 35. Yeah, it worked. So let's do another one now. Which one do you want to try? Negative or a half, a quarter, an eighth? I'm going to try half. I agree. In addition, I like doing that one because if I look at all of those numbers, those are all even. So I know that at least the arithmetic is going to be easy. Whether it works or not is another question. Keep in mind here when I set this up to do my synthetic division a second time, I'm using the result from the previous synthetic division. If you do not do that, you will not be able to find like the imaginary or irrational or potentially duplicate solutions. Like it will not happen. You will not be able to find them. You got to use the result of your previous thing or your previous division. Everybody's okay with that? Hopefully that sounds familiar as well. We did that last year. So that worked. So right now my list for zeros, I have negative 1.25. I have positive 0.5. And then to get my final solution, or to get the rest of my answers, since I'm out of things to do synthetic division with, I'm going to take the quadratic that I had left, set it equal to 0, and solve. So I know that this isn't going to factor, because if it was factorable, I'd be able to see rational zeros that I could do synthetic division on. I don't see any of those left on the graph, so I'm pretty safe to know this is not going to be factorable. So to solve this, I'm going to use the quadratic formula, but I think I'm going to do something else first. What do you notice I could do with this that would make doing the quadratic formula a little bit easier? Landon? Yeah, I'm going to just divide both sides by 8. And you don't really need to do this, but like, God help me, like that makes the numbers a heck of a lot easier to deal with when I plug them into the quadratic formula. So you'll get the same answer whether you divided that 8 out or not. But like, why make your life harder than it needs to be? You know what I mean? My life's hard enough. I don't need like big numbers getting in the way of all the rest of the junk happening in my life. You know what I mean, guys? And this is one where I'm going to not use my calculator to do that, because I notice right here when I look at what's underneath the square root, I'm going to have 16 minus 28, which is going to give me an imaginary number, which my calculator is not going to be able to handle. So I'm not even going to bother trying to ask it. I'm just going to do this part by hand. Everybody okay with the reasoning there? In particular, if you try to use that fraction command that I like to use with an imaginary number underneath, the calculator really doesn't like that, and it just gives you an error and refuses to do anything with it. Even if you have put your calculator in complex number mode where it should give you complex numbers, it still gives you an error there. So I don't know why it's doing that, but it just is not programmed to be able to handle that. So 16 minus 28 is negative 12. I know the negative under the square root makes an imaginary number, so I'm going to put that I out front and drop the negative that's underneath the square root. And then I'm going to try to simplify the radical square root 12. So what I'm going to look for, I'm going to say, okay, are there any perfect squares that are factors of 12? So the perfect squares are like 1, 4, 9, 16, etc. 4 is a factor of 12. So I'm really going to think about this as 4 plus or minus I square root 4 times square root 3, right? 12 is 4 times 3. And I wanted to do that because square root 4 is just 2. Everybody's okay with that? And then I can just take this one fraction and really write it as two separate pieces, each of which I can reduce, right? 4 divided by 2 is 2, and the 2's over here can cancel. So I'm left with 2 plus or minus I root 3. So if I go back to my list here, I started a list here. There it is. So I have 1, 2, 3, 4 zeros, right? The plus or minus counts as 1 each, right? 2 plus I root 3 and 2 minus I root 3. You could write them as two separate, or you can write them together as one thing. Either is okay. Does that feel okay? So the takeaway here is that almost on all these kinds of problems where we're going to find all the zeros, at some point you're going to have to break down and use the quadratic formula to find the pieces at the end, whether they're the imaginary pieces or the irrational pieces or whatever. You're probably going to have to use that quadratic formula. And you guys all remember the quadratic formula? For a quadratic ax squared plus bx plus c equal to 0, x is equal to negative b plus or minus square root b squared minus 4ac all over 2 times a. Right? If you don't have that committed to memory, it might be a good thing to put it on your note sheet for this test because you'll use it periodically, right? Okay. Do you guys want to do another example of this? I can do like one of the homework problems here as another example. Sound good to you guys? All right. The homework here is going to be 36 to 53. Anybody got a favorite number between 36 and 53? 47. That's actually not one of the solving problems, but let's do 48. That's just one higher, and that's a good one. I was expecting somebody to say 42 is their favorite number. No nerds out there that got that joke, apparently. That's okay. So the joke is there's a book called The Hitchhiker's Guide to the Galaxy, where these super intelligent, multi-dimensional beings create a supercomputer to answer like the question, what is the meaning of life? And the answer that the computer gives them is 42.
So Elon Musk put on the roadside ASAP space, right?
I don't know much about Elon Musk, but that sounds like something he would probably do. He seems like a giant nerd. Which is funny because, like, how's that like, what? Wait, what? So, anyways. So here's our polynomial. So if I would start by just identifying how many zeros I'm looking for, in this case that would be 3 zeros. My possible rational zeros are going to be the factors of 40, and then the factors of 40 divided by 2, but I only have to worry about the odd ones, because everything else is, if I do 2 divided by 2, that's just 1 already on the list. 4 divided by 2 is 2 already on my list. Any of the even ones divided by 2 I already have on my list, so I'm just going to not write any of the duplicates. It's fine if you write the duplicates. It's not wrong. You don't have to, like, weed them out or whatever, but Mr. Kulik's just not about writing extra things if he doesn't have to. You know what I mean? While he wants to be precise, he also wants to be efficient. So we've done that part. Let's go take a look at our graph and see what we can see. Oops. Okay, I'll go hit graph now since I have already reset my window back to that standard window. So I see just 1 0 or 1 x-intercept, and it looks like it's at positive 2.5, somewhere between 2 and 3 there, right? And that's good because I do have one of the possible rational zeros is that 5 over 2. So let's do our synthetic division then. Which worked. So we know that one of our zeros is 2.5. Since I've now have just a quadratic left, I'm just going to take that thing, set it equal to 0, and solve. To solve this quadratic, you could start first by dividing everything by 2, just to make the coefficients a little smaller. It makes it a little bit easier to deal with. Now you could use the quadratic formula on this. It wouldn't be wrong to do that. Right? The a here is 1, the b is 0, and then the c is 8. But I would just solve this directly. Right? You don't have an x term, you just have x squareds. So I could just subtract 8 from both sides, square root both sides. So I have x equals plus or minus from square rooting both sides, and I from the negative under the radical, And then I noticed that the square root of 8 is the square root of 4 times the square root of 2. So that's all going to just simplify down to plus or minus 2I root 2. And we're done. Whoa! That's not so bad, Mr. Kulik. No, man, once you get the process, this is, just doing some synthetic division and interpreting what you get. The synthetic division is pretty easy. It's just arithmetic. You have to remember the process. But, once you got it, you got it, What do you guys think? Feeling okay? Lando?
So the test on Monday then?
Yeah, so we have, today we finished chapter 13. Next class will be the review day. You can make your equation sheet and all that jazz. And then we'll do the tests. A test is on Friday and B test will be on Monday. Cool? Okay. That's cool. All right. I think I'm done. I'd give you guys the remaining, 30 minutes or so here in class to get crack-a-lacking on this problem set. You should be able to bang out a good chunk of these guys in a half an hour. Obviously, as you're working, if you get stuck on things, feel free to come on down, ask some questions. I'll get you going in the right direction. Cool? All right, man.